happens when you enter a third dimension. So you don't have X and Y, you also have a Z. So you go from 2 dimensions to 3 dimensions, and you have, what do we call like a flat piece of paper in geometry?
Plane.
A plane. Yeah. So we're dealing with planes now. Okay. Not just a singular line. So think of like the ceiling as a plane, a geometric plane. The floor is a geometric plane. The wall is a plane. Okay. So do 2 planes have to intersect? No. But remember, if we have 3 variables, guess how many equations we're going to have? 3 lines. But not lines now, they're going to be planes. 3 pieces of paper. So do 3 pieces of paper have to intersect? No. So could there be no solution? Okay, so think of the ceiling, the floor, and the floor of the basement. Do those ever cross? No, that'd be weird if they did. Okay. What if if I could put these, they're all vertical, and I could stick this one right through there. Think of 2 walls. What happens when 2 walls cross? They make a corner. So what shape do I have running up the corner? Right angle. Vertex. So let's just say 2 of them. The square. So if they crisscross right here, how many points do they have in common?
1.
3. Well, if they have 2 or 3, can't you connect those two or 3 points and make a? Say it. No. That wasn't it. I thought you were going to say it. So 2 papers intersect. Geometrically, what shape, what objects will they create? No. Say the second word. Line. They make a line. So these 2 walls intersect right here. You see the line running up and down? Okay. Now, use your imagination. Imagine they built this really weird, and they had a 3rd wall coming out at an angle. Isn't that cool? Okay, so we had a 3rd wall coming out at an angle. It also goes right through here. What if all 3 of those walls intersect in a line? They share a line together. Okay? Okay. Still got that mental picture up here? Take that wall that's coming out at an angle and flip it sideways so it levitates. Okay? Now that wall's coming through here. Do all 3 walls still share a line? Not up and down, right? Because this one's coming in flat. This one's coming in flat right through here. So this one's not like this. It's not going to be running alongside the line. It's going to be coming at an angle to the line. Now these 2 walls share a line, but this one, when you put this one in the mix, it only shares 1 single point, right? So that point is going to have an X value, a Y value, and a Z value. And that's the goal when we get 3 systems and 3 unknowns, is to figure out what's the X value, what's the Y value, what's the Z value. Okay? Now, that elimination is going to be key. We're going to use that elimination all the way through this process. Okay, so that's where we're going to get more practice with the elimination, but it's just going to be more steps. Okay? So, this is the pictures of what I was talking about. So this is page 161. You did a great job trying to visualize it. That's the big thing in mathematics. If you can visualize and see things in your head, it's a lot easier to work things out on paper. So you could have all 3 pieces of paper crisscrossing and they share 1 point in common. You could have all 3 of them go in the same direction. They share a line in common. That's when you had the 2 walls and the 1 wall still vertical going through there. They could all be the same plane, or they may not share anything in common. 2 of them may, but the 3rd one doesn't. So you can have no solution as well. This last one would be like the ceiling, the floor, and the basement floor. This middle one would be the ceiling, the floor, and a wall. Is there ever a place the ceiling, the floor, and the wall all intersect in the same point? All of them intersect. No, because that ceiling and floor will never intersect. Okay, or you get a triangular room. Go crazy and they're looking for a fourth corner. Okay, so here's what the basic problems, without any trying to write it out from words, this is what they look like. So you see we have three equations, we have three variables. Okay, so that's the first one we're going to do, or I'm going to write that one down. So that 1A. You will be able to know the steps to this fairly well. The steps will sound familiar to you. The wording I use will sound familiar to you. Okay, got your thinking cap on? Tired of your sleeping cap. Okay, first thing we're going to do, now I'm going to leave some room to work here. I'm going to write my steps clear over here. So we have to choose two of the equations. And we're going to eliminate one of the variables. So the first thing we're going to do, we're going to take our system. We're just going to pick two of the equations. And this process we're going to have to do twice. And we're going to eliminate one of the variables. Things with ones are usually good things to pick. So which, one or a negative one, which of the three equations has a 1 or negative 1 in front of a variable? You see that one right there?
Yeah.
Okay. So, because if there's a 1, it's really easy to multiply by something and get it to cancel off. Now, there's no wrong way to go with this, but there are easier ways. Okay. So you could say, I want to choose the first two, and I want to cancel off the x's. We could do that. We could cancel off the y's. We could cancel off the z's. It doesn't matter. Okay. So, in this case, what do you want to work with? Okay, we're going to start with this. Keep in mind, you don't have to do it you don't have to pick these last two right here. But for now, we're going to choose these last two and we're going to cancel off the z's. So if this is a positive 2, this needs to be a negative 2, so which means I have to multiply the second equation by positive 2. So we're going to take the second one and we're going to take the third one. And for right now, we're going to ignore the first one. We're not going to use it. I'm not giving you a lot of problems. I don't want you to rush through this. Because one little minus plus mistake or one little wrong calculation is going to throw the whole thing off. And it is a real nuisance to try to go back and figure out where you messed up. Because it's going to be one little thing that you messed up probably clear at the beginning, and it threw everything else off. You have to redo it all. Okay? Attention to detail. That's going to be the name of this game here. So double check your work before you move on. Try not to go too fast. Okay? So we're going to add these together just like we do elimination. So negative 13x plus 11y. The z's cancel off, and I'm left with negative 61. Okay. So we're going to leave this here for now. We'll come back and use later. So this equation right here, we're going to come back and use that later. So just hang on to that, stick that in your pocket. Okay, so far okay. There we go, second step. So we're going to use the equation we didn't use in step 1. And one of the other equations, so we're going to use the equation we didn't use in step 1, so in this case the first one, and we have to use one of the other two equations to eliminate the same variable. The same variable you did in step 1. So we're going to go through the same process again. We're going to use the equation we didn't use in step 1, and we're going to use one of the ones that we did use, and we have to eliminate the same variable that we did. So in this case, we have to eliminate z again.
61.
Yes. See? Good. See, you got that. Okay. So we have to use the first one. Which one do we want to use as the first one? Third. I would use the third one again. It's not wrong to use the second one. If you use the second one, you'd have to multiply both of them by a number. So we have to use this one. So we have to use 2x plus 4y minus 5z equals 18. So now I'm going to use the third one again. And we'll see if we can get this figured out as I write it down. So try to save a step here. If this is a negative 5z, what does this one have to be? Is that okay? This one's a negative 5z. I'm using this one down here. This one's a negative 1. I need this one to be a positive 5. So I'm going to take this one times negative 5 at this case. Okay. So you go back to the original ones, and you can multiply them by a different number. $85. Is that okay?